Good morning, my dear students. I welcome you to my next online class, Chapter 8, Winds, Storms and Cyclones. Last class, maybe a week before, we learned what is meant by wind and the two characteristics of wind, that is direction and speed. And we also learned about atmospheric pressure. This atmospheric pressure is the reason for wind or breeze or storm or cyclone. That is a cool breeze or a normal wind or a tremendous cyclone or a storm. We also learned some 3 experiments to prove air exerts pressure. We call this as atmospheric pressure, and based on that we are going to continue with the remaining lesson. In today's class we are going to learn certain other topics which includes air expands on heating. So actually you should have learned in lower classes that all the objects expand on heating. Solids expand on heating, liquids expand on heating. Like that we are going to learn today, that is gases also expand on heating. In the name, air expands on heating. So air is none other than gases. Okay. So this is the first topic we are going to learn today, that air expands on heating. As we have learned in heat lesson, chapter 4 heat, we are again about to learn another concept, that is warm air rises up. The reason is warm air is denseless compared to a normal air or cold air, and so automatically it rises up. So this is the second concept we are going to learn with some few examples. And the third, we are going to learn the generation of wind currents, maybe in the whole globe, that is in the whole earth. And secondly, we are going to learn how land breeze and sea breeze are formed. So certain things we have learned already in chapter 4 heat, and in the intro, that is in the last class also, I said certain concepts which is being repeated. With that we will finish today's class, and the remaining concepts we shall learn in the next class. Okay. The first activity of today's class is to show that when the speed of air increases, the pressure is reduced. Again I repeat, the aim of this experiment is to show or to prove that when the speed of air increases, the pressure is reduced. For this we take 2 balloons, fill a little amount of water in both the balloons to maintain a weight in the balloons, and hang these balloons in a stick using a thread such that they are very closer but they don't touch each other. So in that way the balloons should be inflated and tied in a stick, and we have to fix the stick somewhere or hold the stick. Now I blow air in between the balloons. Again I repeat, the balloon contains a little amount of water with some air inside. Both the balloons have little amount of water with some air inside. I tie it or fix it in a stick such that they don't touch each other, but there is only little space between the balloons. When I blow air in between the balloons, what happens, based on the speed of my blow or speed of my wind that I blow, the balloon will start to move towards each other. They touch each other. This shows that when the speed of air increases, what I am blowing is the speed of air, so that creates a pressure difference, and because of that, the pressure, to maintain the pressure, the balloon starts to get closer and touch each other. The second activity is to show that air expands on heating. For this, I take two glass bottles. I stretch a balloon in each bottle. So two bottles, in each bottle I am stretching a balloon such that it covers the opening or mouth of the bottle as it is displayed in the photo. One bottle is inserted into a beaker containing hot water, and another bottle, actually both the bottles are empty bottles, okay, another bottle is inserted into a beaker another beaker containing cold water with ice cubes. So one with the hot warmness and second with the coldness. So what you can find is the bottle that is inserted into hot air, in that the balloon starts to inflate, that is expand, whereas in the other balloon which is fixed into the bottle placed in a cold water, the balloon will start to deflate, that is the balloon will shrink. So this is because in case of the balloon or the bottle that is kept in the hot water, the hot water initiates warmness inside the bottle, so the air inside gets warm, and because of that the air expands. So already there is sufficient amount of air inside the bottle and the balloon, and now the air expands, and that makes the inflation or increase in the size of the balloon in the first case, that is the bottle that is kept in the hot water. Whereas the reverse process takes place in the second beaker where ice cubes are placed. So because of the low temperature, the air inside the bottle will also start to shrink. Expansion, contraction. Okay, so the air does not expand, opposite reaction takes place. So the air shrinks, and because of that the small amount of air that is in the balloon also will start to shrink, and because of that the balloon deflates. That is opposite of inflation is deflation. That is, in first case the balloon expanded, which is called as inflate, whereas in the second case in cold water the balloon deflate, that is it start to shrink. Even the air, small amount of air that was present in the balloon will be reduced, and because of that the balloon shrinks and falls down. This is known as deflation, and this shows that air expands on heating. The second concept is warm air is lighter than cold air. So we have learned this already, but still we are going to learn with some new example. Okay, so what we have learned already is that warm air is lighter than cold air, and when there is warm air because of sunlight or because of heat etc., automatically the air becomes lighter and starts to move. I hope you know, whatever that is lighter or denseless will start to move upwards. For example, if you blow air in water, air is denseless, and because of that it always rises up. The air bubble that is found in water always rises up. And if you are throwing a stone or a rock, or maybe you are jumping into water, these rock or stone or ourselves we are all dense compared to water, and so we always sink down. So this is the concept, that is dense objects go down and denseless objects always floats or rises up. Okay, so similarly with related to air, we come across warm air always rising up, and this is the reason for the protection of it. So that we'll learn later. Here what we are about to learn is the examples to show that warm air rises up. For example, in a candle, you can find the flame always moving up. So that is, in candle you have the wax which is connected to the thread at the center. Okay, so in the thread actually you have the wax slowly which enhances burning, and when the flame burns, so actually the air surrounding the candle or the burning candle will be hot, and that starts to move up, that makes the flame moving upwards. Okay, so actually it is because of the air that is moving up which appears as if the flame is going upwards. Okay, so this is one example to show that warm air is lighter than cold air, and warm air always moves up. Okay, then second, when you burn something, you may burn a paper or something, you can find again the smoke arising from the paper or coal or some other burning substance, combustible substance, and even in that case the smoke, that is the black colored smoke, you can find always moving up, and this also shows that warm air is lighter and it always moves upwards. Okay, let me add one more to this, that is with regard to this smoke, that is when you come across a fire accident. Okay, so actually it should not happen. So when you are facing this kind of trouble, okay, when there is a fire accident somewhere, you are not supposed to walk upright always. I mean, when you escape from that building or from that site, I mean where fire accident has taken place, you should not run upright always, you should bend and move. Okay, so in the sense you should almost crawl, because again when I say fire accident, you come across smoke there and all those smoke will rise up, and so it is better to bend yourself and move such that you are free from smoke, because when you are in smoke, what will happen, you will consume the smoke, that results in suffocation and you may become unconscious. You cannot escape from that place. So keep in mind, you should always bend from the smoke and you have to escape. That is, you should not walk upright or run upright from that place. I hope you understand. Okay. Next year you are going to learn about combustion, that is burning. Okay, burning of a substance. So you have there is a vast idea about combustion. Let me give something that is related to our concept. Okay, so combustion is of two types, namely complete combustion and incomplete combustion. A complete combustion which takes place when there is sufficient amount of oxygen, and an incomplete combustion takes place when there is lack of oxygen. First of all, you should know that combustion, that is for burning a substance, it needs oxygen. Okay, so for example, burning of a candle or burning of agarbatti or burning of a paper, so the the main factor that is needed for combustion is one, oxygen, apart from other concepts. So I'm just sticking on to our concept. Okay, so if there is no oxygen at all, which means that product will not burn. This you might have learned in lower classes, where you just take a candle. Okay, so keep it in a water, okay, a plate or a basin containing water. You lit the candle and cover it with a glass tumbler. So this you might have even learned in primary school. Okay, so when you close the glass container, I mean the candle with the glass container, so the candle burns for a little time duration and then it switches off, which shows that one burning of a candle or burning of any substance needs oxygen. If there is no oxygen, it will not burn, because here we are closing the candle with a glass vessel which stops the entry of air into the setup. So what happens, the candle burns till there is oxygen inside, and then it switch off. So this shows that burning, not only candle, burning of anything needs oxygen. Okay. Coming back to combustion. So I said, to burn a substance, we need oxygen. If there is sufficient oxygen, complete combustion takes place, and if there is if there is lack of oxygen, incomplete combustion takes place. Now let me link this to our concept, that is, when there is complete combustion, less amount of smoke is produced or no smoke is produced, and when there is lack of oxygen, what happens, more amount of smoke will be produced. Okay, just keep in mind, smoke is produced mainly because of lack of oxygen or because of incomplete combustion. Okay, again come back here. So I said two examples for warm air is lighter than cold air, and so it moves up. So first example is the flame of a burning candle. So always it appears it moving up. So actually it is because of the warm air that is rising upwards. Second is smoke from any burning substance. Always it moves up, and that is also because of smoke is none other than dust particles along with warm air. So that's why smoke is blackish in color, because of the presence of the dust particles especially. Okay. Then third, you might have heard this chapati. Okay, so in chapati, where when it is in chapati you have flour along with the water molecules. So it is rolled into a flat, and it is put in a hot plate, or sometimes it is kept on a stove. So what happens, when warmness, when the chapati gets the warmness, the air inside will also become warmer. That is, the water molecules will start to evaporate. So it becomes gaseous form, that is steam. Okay, so this gaseous form of water that is found in the chapati tries to move upwards, but actually what is above is a layer of the flour. Okay, so in between the flour you have the water molecules. It becomes a steam. It starts to rise up, and there is no chance of rising up because the whole chapati is made up of flour. So what happens, it starts to inflate. So this is another example of warmer air becoming lighter, and second one is since they are lighter, they start to move up. Okay. In this third activity of today's class, I take two paper bags. I fix it to a stick as it is shown in the figure or in the diagram, and the stick should be hanged on something such that it is not disturbed. Secondly, we have to see to that such that the stick is balanced. Okay, based on that I have to hang the stick. Now I bring a burning candle nearer to the first bag. So see to that we should not burn the paper bag, but the candle is brought such that it is the flame is inside the bag. Okay, so much care should be taken such that the paper bag should not be burnt. When I bring the candle near any one bag, what happens? The air inside the paper bag will become warmer, and because of that, as we have learned before, the warm air always rises up. So here, since one bag inside, the air inside one bag becomes warmer, it starts to move up, thereby disturbing the balance in the stick or balance in the setup. So this shows that warm air always rises upward. So already we have learned about candle, we have learned about smoke, we have learned about that inflation of chapati, and now this is another activity to prove that warm air always rises upwards. So this concept actually is involved in this hot air balloons. You might have seen this hot air balloons inside which you'll find a fire, and based on the burning using a gas, based on that the hot air balloon will start to rise up. It moves from one place, it can be controlled, and that can be used to move from one place to other. Under the topic generation of wind currents, we are going to learn two concepts. One, uneven heating of earth in the equator and poles, and the second one is uneven heating of land and the sea. First let us start with the uneven heating of poles and equator. So here we are going to learn how this wind currents are generated, which a part of this, that is your second concept, we have learned already in chapter 4, heat. So before learning this first topic, that is uneven heating of poles and equator, so I just want to give something else. That is, I have a small ball of my daughter. So let us imagine this as a earth. Okay, so a spherical object. You can imagine this as an earth. So there are many rings in the ball which we can imagine as latitudes. Okay, so there are no longitudes. Okay, so I hope you know what is meant by latitude and longitude. That is the horizontal imaginary horizontal lines that are found in the earth are known as latitudes, and the imaginary vertical lines that are found in the earth are known as longitudes. Okay, you might have learned this social science. If you don't know, at least now you know. Latitudes are the horizontal lines and longitudes are the vertical lines. So these are imaginary lines to denote a particular which makes easy to denote a particular area, to find a particular area, etc. Okay, so latitudes and longitudes. Okay, so now let us imagine these white lines. I hope you can find these white lines. These let us imagine as latitudes. So the line at the center is known as equator, you know. Okay, and let us imagine these two are the polar regions, North Pole and the South Pole. Okay, or otherwise known as Arctic regions. Okay, so first thing what I am trying to say is that I just take a torchlight to let this be a sunlight. Okay, so I am just imagine this is the sunlight. Okay, so here the earth is there. I hope you know earth is slightly tilted. Okay, so in that way actually the earth revolves around the sun. Okay, so this is not exactly sun, this is just a torchlight. Okay, so first thing what I'm trying to say is that is the sunlight falls more at the equator than at the poles. I hope you can understand. The sunlight always falls more at the equator than at the poles. The reason is the poles you can find that the poles are, the polar regions are, okay, so if this is the pole, okay, so you can find so if this is the equator, okay, if this is the equator, so you can find the distance. Okay, so let us take this. So up to this, which means the equator is nearer to the sun compared to the poles. Okay, so here you have poles, so almost this much distance. Okay, so again I repeat, so here the distance is up to this. Okay, I am holding the finger there. Okay, same, just compare here, poles, so you have this much of distance. Okay, so this is the equator and this is the polar region, so you have this much gap. What I am trying to say is that the equator is nearer to the sun compared to the poles. Okay, equator is nearer to the sun compared to the poles. Even above you can find, even though it is tilted, you can find the equator and the poles. Okay, so here is the equator and here is the pole. I hope you understand. Okay, so in that way you come across the equator is nearer to the sun. The distance will be smaller compared to the poles, and this is the reason why polar regions we come across, or Arctic regions we come across presence of more snow, presence of freezing temperature, etc. Because sunlight is far away from the polar regions. I hope you understand. Okay, I don't know how far I'm able to explain this. Okay. Anyway, with regard to this concept, that is where you have the equator, so where you come across more sunlight compared to the polar regions. So what happens here, that is in the equator region, that is we are talking about the atmosphere. Okay, the atmosphere or the air that is found near the equator region will become warmer, will become warm faster. Okay, so what happens, these air will start to move out. Okay, so imagine, actually, even though the earth is in this region, the air from here will start to move, okay, like this, in this direction. Okay, because full of gases. Okay, so it will not move in this order, so it will move in this order, that is perpendicular to the gravitational force, or in an opposite direction of the gravitational force. Okay, right. So when the air here from the equator moves away, what will happen, the air from the polar region start to move inside. Okay, from North Pole and South Pole, the air will start to move towards the equator, and this is one reason how wind is generated. That is the main reason how wind is generated. Then one more thing, that is, it is not that always the air will move from north to south. The air will also move from the south pole towards the north, that is from north pole towards the equator, similarly from south pole towards the equator. So in both the directions you come across movement of air towards the equator. So this is the first concept. The second concept is land breeze and sea breeze, which we have learned already, where during summer season, where the air that is found near land will become warmer faster compared to the sea, compared to the air that is found in the sea. And because of this, the air that is warmer in the land surface starts to move upwards, and that results a pressure gradient. And to balance the air pressure or atmospheric pressure, the air from the sea will start to move towards the land, and this is known as sea breeze. And this sea breeze, which comes from the sea surface to the land surface, contains more amount of water, because when there is a warming up of air above the land surface, there will be also warming up of air and water. Okay, that is, in sea, water will start to evaporate because of the high temperature, and so the air that is above the sea or ocean will contain, along with air, it also contains more amount of water molecules, that is moisture. Okay, so what happens when there is sea breeze, the air above the sea level with the water will start to move towards the land surface, and this is the main reason for the formation of rain. Okay, so this is known as monsoon winds. Okay, so the monsoon winds which actually causes rain. Okay, similarly in winter season, where you come across more amount of hot air in the above the sea compared to land, so that air will start to move upwards, and again there is a pressure gradient, and now air from the land surface starts to move towards the sea or ocean, and this is actually known as land breeze. Okay, so where you come across this seasons because of this kind of movement of air. Not only seasons, formation of cloud is also because of air, rain is also because of air, creation of storms or cyclones is also because of air. Only thing is that if it is the movement of a very cool air, it is known as breeze, and normal air, the movement of normal air is known as wind, and if the same wind with high force, it is known as storm, and this due to the air pressure, if it causes a twist, then it is known as cyclone. Now let us end today's session with these concepts. So certain concepts are maybe difficult to understand. Certain concepts you have to learn the book immediately after listening to the class. So follow that, immediately take the book and go through what has been taught. Compare what I said with what is given in the book, so that it will be easy to record in your mind. Okay, so we'll finish today's session with this. Remaining concepts we'll learn maybe next class. Today's assignment is you just write these points that are displayed in the screen in your notebook, taking a fresh page, and always write that day's date. Okay, so when the assignment is given, that day's date you write in the notebook, so that it will be easy for us to evaluate your notebook. Okay. Just a few sentences only which describes the meaning of certain words. So write in your notebook neatly, and always after finishing the assignment, draw a line. If it is a question answer, after each question answer you draw a line. If it is an exercise or points like how you are going to write today, you after finishing all the points you just draw a line. Okay.